Although our air transportation system is the best in the world, there are still inefficiencies. In a busy airport environment, a lack of communication and coordination can be issues amongst the operators who are responsible for managing the phases of flights. And with the growth of air traffic, terminal airspace is becoming even more congested and inefficient, which can lead to bottlenecks on the surface. So how can we find ways to make the current system more efficient? This is where NASA's ATD-2 demonstration comes in. The ATD-2 testing focuses on ways to integrate the different systems that can cause these inefficiencies into a new, innovative system. It will integrate arrival, departure, and surface technologies, or IADS, and other older technologies to improve the traffic management system at the airport. This will increase predictability of aircraft movement times, improve overall system efficiency, and reduce fuel burn and emissions. That means that this tool will help airlines save money and passengers save time with less delays. In order to learn how to implement this system nationwide, NASA and its partners are testing the new systems in a real-world environment. Air traffic controllers and airline personnel will evaluate the system as they use it to manage air traffic operations at a busy hub airport.
I've been involved with NASA since about 1995 and been participating in a lot of their demonstrations. I knew they were the right people to go to, and we got together and we talked it through.
After looking at several options, Charlotte Douglas International Airport in Charlotte, North Carolina, was chosen to conduct initial testing. Charlotte was ideal for many reasons.
It turned out when the FAA and NASA were looking for a location to demo this technology they were developing, Charlotte turned out to be an ideal location, primarily because of where we're located along the East Coast and the multiple centers that we deal with. We have a very difficult time getting aircraft off the Charlotte airport into the overhead streams, and we have 9 very definite arrival and departure banks a day at Charlotte with about 45 minutes of recovery time between each of them. You could not have tested a technology such as this at an airport like Newark, LaGuardia, or JFK. You run the risk of grinding the whole system to a halt. So Charlotte was an ideal location to roll this out, and eventually this technology, after it's incorporated into TFDM, will be rolled out to all those other busy airports. Anybody who takes a look at the Charlotte Douglas International Airport and sees a map of it, sees the runways of a major international airport. If they look closely, however, they'll see that we have the ramp space of a mid-sized regional airport. And our departure and arrival banks at Charlotte pretty much overlap 9 times a day, and we move between 75 to 80 arrivals and 75 to 80 departures through a very small confined ramp space at Charlotte. We can't build our way out of this one. To find the inefficiencies that are there and to make things more efficient, we're going to have to use technology. And once we begin using this technology and are sharing the information that we have, and the airlines are sharing the information they have with us, we should both be able to come to a much better solution to this problem and become more efficient.
The partnership between American Airlines, the Charlotte Airport, NASA, the FAA, both headquarters and locally with our controllers, is exceptional here. And we've worked very, very well as a team to achieve the objectives that we wanted from the project. And I think it's been a huge success because of that collaboration.
We're very excited about this partnership in Charlotte especially, and we have not only American Airlines involved with NASA, but the local FAA folks are involved, the airport authorities involved. It's a real true collaboration. The airport surface for many, many years has been sort of the black hole in terms of understanding what's happening on the surface and how that connects to the overhead stream of aircraft. So what we want to do is be able to give the traveling public, whether it's American Airlines or other carriers, a more predictable experience, because there's still a lot of uncertainty today when you push away from the gate and you wait to take off, and I think we've all been through that at one time or the other.
The ATD-2 software will combine multiple concepts and technologies, including the FAA's 3 major operational decision support system technologies called Traffic Flow Management System, Time-Based Flow Management, and Terminal Flight Data Manager.
Some of the most powerful stuff, it's the under-the-hood stuff that NASA has done with this dashboard that gives us a very quick look of how the health of the airport is going. We measure throughput in the FAA by number of arrivals and departures at the airport. And what we're trying to do is find the inefficiencies that are there and optimize the throughput by putting aircraft in the best possible place to meet their slot in the overhead stream. We have very high hopes that we can make things more efficient, and we'll be using this equipment to do that.
Another big technology change is just the exchange of information amongst the different players in the system. Right now, each of the entities, the facilities that are responsible for controlling the traffic, pretty much operate within their sphere of influence without a lot of information flowing between the facilities. And so a big part of ATD2 is to help that communications flow amongst the different people that all are responsible for solving part of the problem. Our objective is to improve the predictability of these integrated arrival departure surface operations, because a lot of the inefficiencies that are inherent in today's system are due to the lack of predictability. People do not know what to expect when they're managing the traffic, both on the FAA side and the air carrier side. And so they're conservative in their approach. They introduce larger buffers and greater than needed traffic management constraints because they don't know what's going to happen. But by sharing information amongst the parties that are trying to solve the problem and tying it all together with a time-based scheduling system, we expect to improve the predictability and help folks be less conservative in their approach to managing the traffic, to provide smaller buffers in the system.
It's a lot of different systems that may be out there today operating separately, but if we can connect them through networking, have the information and data flowing between the systems. But it's not just the fact that the data and information is beginning to flow across networks or into the other systems. It's what you do with that data also. So a lot of our technologies, you could think of, the kids today might think of as apps. So these are applications that the operators can use, but it's telling them very important and unique information about the schedule, what aircraft should be in position at what time in order for the overall operation to work most efficiently. And that information will be shared with all the participants, whereas now only part of the information is usually resident with each of the participants. But with that picture that everybody has, everybody knows what we're working towards, it can function a lot more efficiently.
This increased predictability and merging of technologies has the potential for huge benefits. Initial projections of 10 congested airports show the potential for ATD2's departure scheduling to substantially reduce overall departure delay by 40% and enable flights to absorb their delays at the gate, which leads to more environmentally friendly operations. Over a 20-year life cycle, conservative estimates indicate a potential savings of $8.2 billion.
I have been in the airline industry a long time, and I can say over the last 15 or 20 years I've been involved with several different projects, if you will, and partnerships with NASA. They've all yielded very good results. I think this is sort of the most exciting of all because it brings a lot more of the pieces together in connecting the airport itself with the airspace around the airport and overhead.
I have seen more benefit from this program than probably any other thing I've worked on in my 36 years as an air traffic controller.
It is clear that change is coming to our national airspace, and fortunately, NASA, the FAA, air traffic controllers, and their industry partners are all working together to make sure that these changes are not only seamless, but improve our quality of life and the overall transportation system. Although you may not see the inner workings of this unique system, the increased predictability will undoubtedly make flying less uncertain and much more enjoyable.